Alright guys, today we're going to continue on with talking about how light is created. We're going to look at some more examples. We saw in our last ed puzzle that the different elements are able to produce different colors of light, and we looked at some like hydrogen bulbs and helium bulbs and neon bulbs, etc. Now it doesn't just have to be gases, so all of those were examples of gases. And in the stock room I showed you guys how UV light can excite the electrons in certain atoms, causing them to emit light. So like the atoms that we find in a highlighter and things like that. Well, we could do it really for any atom. And so I have a whole bunch of different ones here that are not gases. I have things like barium and what else do I have? Copper, strontium, cobalt, potassium, sodium, calcium, and lithium. I have a whole bunch of different elements here, and what I did is I dissolved them in water. So if we hold it up and take a look at it, you can see that I took the element, I dissolved it in water, and I stuck a little wooden stick in there, and that wooden stick is absorbing some of it. So what I'm going to do is I'm going to be lighting the Bunsen burner, and I'm going to be using the heat from the Bunsen burner to excite the electrons. So it should go in as heat, the electrons should get excited, drop back down, and re-emit that as a new color of light that's unique to the element. So we go ahead and light the Bunsen burner, and we see that the Bunsen burner does have, a little bit of that natural characteristic blue. I could adjust the collar at the bottom here and make the flame a little bit more intense. And so that blue color is what we're naturally seeing, so it's showing up kind of nice on the black shirt that I've got here. So what we want to do for our lab today is we're going to run these flame tests, and we want to be able to identify what elements are going to produce certain colors. And we actually use this technique to identify unknown materials all the time. This is how we know what the sun is made out of. This is how we know what the stars are made out of. And we're going to do the same thing here. Now we could use a spectroscope for this, but it makes it a lot more difficult. And I've chosen elements that all have different colors, and you don't necessarily need the spectroscope for it. So as I go through these, I'll let you know what element we're observing, and on your lab paper that you're taking your recordings on, you're going to basically say, this is barium, so we'll do barium first, and when I put it on fire, I'll let you know when I see the color actually. Sometimes it takes a minute to heat up, and you're going to record the color that you see. So the first one is barium, the symbol is Ba, and so we're going to go ahead and I take the stick, and I'm going to put it in the flame down low, and hopefully it'll light and it'll change the color as we go up. So as soon as I see the color changing, then that's the characteristic color right there. So what you want to call this is up to you. The name of the color is not important. You being able to identify what element is attached to it is. We remember that we call this a qualitative observation. Okay, so for me, I would call barium sort of like a pale yellow. That would be me, how I describe it. But if you want to call it by something else, if you want to come up with some fancy name, sunshine or something like that, then that's fine with me too. But this is what we're seeing for barium. It's kind of like a pale yellow color. And if I leave it in for too long, the stick starts to catch on fire and the color changes. So we don't want that to happen. But this would be barium. It's the real pale. Okay. Let's try another one. So now we'll go to copper. So copper, this is our copper here. And so the copper, when I put this one into the flame, I'll let you know there it comes. So how would you describe the color for copper? Dip it again. There we go. So we're getting a nice copper color here. So you can really see it high up. It's really bright down low, and it's hard to see the color there. That's the copper. The next one we have is strontium. So this is strontium. Strontium is Sr. I know that things are backwards for you. Well, they are on my screen. Maybe when it records it flips it. But strontium is Sr. Put strontium in. Okay. So we strontium is kind of like a reddish color. Whatever you want to call that, it's up to you. So we see the real bright area down in here that's showing up on the iPad. But the characteristic is that sort of reddish color up above. That's strontium. Here's cobalt. Okay. So we see the cobalt here. The cobalt in the flame. Cobalt is kind of interesting, and if you look closely in the flame, cobalt gives you a lot of sparks when you see it. Oop, caught fire there. So we put it in, we actually see like sparks that are coming out of there for the cobalt. Next one is potassium. Put potassium in the flame here. How are you going to describe that? For me, I kind of call it a lavender. It's getting real pale. Dip it again. Very pale. That was the potassium. Next we have sodium. Whoa, you see that one? Sodium is crazy bright. They've made lamp bulbs out of sodium for a long time because of how bright it is. Once again, I don't care what you call it. You could call it Pikachu, you could call it sunshine, whatever you want. But make sure that you describe it differently than barium that we saw earlier. You need to be able to tell the difference between this and barium. So this one is really bright. And that's the sodium. Oh, this one's a tough one. Calcium. Different. Some of you are like, wait a minute, what? That looked exactly like the last one. No, it's different. Okay, this one's darker when you look at it from the last one. Here, I'll put them in side by side. Let's do this. So this one's sodium. This one's calcium. See this? That's sodium. And there's calcium. You see the difference? Much brighter, more yellow to it. This one's got a lot more red in it. Okay. Also, the brightness is a huge giveaway. Look at how dark that one is. So they're both yellow or orangey, but one of them is just a lot darker orange. The calcium. I know it's tough, but you do it a few times and you get used to seeing it. And then this one is lithium. Here's the lithium. There it is. Now sometimes people go, wait a minute, we saw one like that already. No, this is very different. I'll compare it. The one that most people get confused with is strontium and lithium. So we'll show those side by side. So here's lithium. And then here's strontium. Give it a second. There it comes. This one is much more purple. This one is more on the red side. It's not as much purple in it. It's not showing up great. Let's see, there it is. It's nice. iPad's having a little bit of trouble with it. Okay. This one was the lithium. Okay. So we've got the colors recorded, right? We've got the colors recorded. So now what we're going to do is we're going to use those colors to identify some unknowns. So we're going to shut this off for a second. We have some unknowns, and I want to know what these unknowns are. And this is how we do a lot of qualitative chemistry is we know the colors that things form, and then you get some unknown chemical, and that chemical is going to produce a very specific color. Okay, so here's the first one. So let me get a little bit of sample here. So what I'm going to do is I'm going to do the same thing, but this time instead of dissolving it in water, I'm just going to go ahead and put a sample on the dish. Okay, so we got a sample of some white crystals here. Okay, sample of white crystals. And then I'm going to heat it up. So I'm going to heat it up using some methanol. So we'll go ahead and we'll put a little bit of methanol on there. And then go ahead and put some of sample 2 on here. And then we're going to put some of sample 3. So remember, it's our goal to try and figure out what these are. You're going to be telling me what these unknown chemicals are. Okay, so I've got some methanol on each one of them. And we're going to go ahead and light it and make some observations. So I might light each one of these. So sometimes it just takes a second to get hot. So there we go. So we've got sort of a real bright, sort of yellowy orange color over here. This one, right, this red, and then we've got this guy over here. So we're trying to, this one's not doing great. I might need to put some more on that one. Trying to figure out what these unknown chemicals would be. So what are we looking at here? There, it's actually showing up pretty nicely now. Okay, so on the conclusion questions for the lab, so you basically what you need is you guys have to have some kind of table. Lithium was this color, strontium was this color, potassium was this color, right? All your recordings. And then you're going to have some questions to answer. And those questions are going to have, one of the first questions is going to say there were 3. What were the 3 unknown chemicals? So we'll say that this is unknown number 1. This one is unknown number 2, and then this sort of green one is unknown number 3. Okay, so what is the identity of each of these? And then there will be a few conclusion questions for you guys to answer as well. Okay, this is called a flame test. We're using heat from a flame to excite the electrons in the atom and have it produce its unique color. Thanks, guys.